What's up guys, this is Ronnie once again. Welcome back to our channel Total Technology. Um, I think after quite a long time I am uploading this video. I was very much busy with some other topics like mostly I have also doing some uh, course for Udemy and all, so I was not able to upload or shoot some videos for this channel. But anyways, I'm going to do some what do you say, some important stuff from now onwards. So as we promised, like we are going to start machine learning series from the month of April or May. So this is the first or introductory session for that. So today I'm going to start today actually not me, like my other two friends like Amit and Shupratim also going to contribute on this series as well. So mostly the first 2 or 3 weeks will be the prerequisite for machine learning things like NumPy, Pandas, or some linear algebras, probability, multi-valued calculus, and other statistics or mathematical thing. And after that, we are going to start very slowly with the core concepts of the theoretical part of the machine learning. And once that is done, then we will be going to start with the toy data set, and after that we'll be creating our small models, and after that we'll be going to touch some Kaggle data sets or some pre-existing data set. And once everything is done, then you guys can carry on our techniques or our tutorials for doing your real-time projects or other things. And in meantime, in between, if you guys are having any question, any doubt, you guys just do let us know via Facebook comment, in our Facebook page, sorry, in our YouTube channel, our email IDs, and we have also it is not completed yet. Also, our website is under the development phase. So once this is done, then also it will be easier for you guys to interact with us. So without wasting much time, so I'm going to start the NumPy series. This is basically one of the core building blocks of Python, statistical or mathematical or like uh, machine learning topics, like whatever scientific or mathematical or algorithm based operations are developed or still developing or underdeveloped, are mostly using this NumPy library. It is one of the fantastic libraries available in Python. So if you are going to start, or if you are going to pursue your career on machine learning or AI or data science or data scientist or data analytics, whatever, then you should know the core concept from basics to advanced level of this NumPy thing. So I'll try to cover up each and everything, but I'm not sure because I'm also not an expert. I have also learned all these things a couple of months ago, maybe 3-4 months back. So I thought of contributing back this to the community, because I'm not a college graduate, or sorry, I'm graduate, but I'm not a master degree holder, or I'm not a PhD holder on machine learning or data science kind of a thing. Yes, I do like maths. I do have interest in machine learning and this Python related things. So YouTube was my YouTube was my university, and I started learning from YouTube only. So I thought of creating some consolidated course for you guys. So I'm just doing it. So hope you guys will enjoy it, and I'll be able to contribute something to your future development. That is only my goal. And in between, if you like our channel, like our videos, just support us by putting some positive or some feedback related comments. We'll try to do something as per your request or recommendation. So let's start. So first of all, you have to import this library, and like this. So this is the library, and you can use it as an alias. So import numpy as np. So this is the global standard. You can use anything but anyways, I'm not going to do that. So you can understand. So it is like import numpy as np. So why numpy array? Because if you guys thinking that there is already one pre-existing array is available for Python, but then why numpy array? Because the existing Python array is not capable of like giving the opportunity or feature or the facility to operate or process some multi-dimensional all. It is kind of list only, but again list is heterogeneous, array is homogeneous. So you can think about, like, you can compare between list and numpy array. Why list, or why you should numpy array, why not list? Because list is already available, but again list is a single dimensional thing, you cannot create as a multi-dimensional. But numpy array is a multi-dimensional array where you can do whatever you want. But just remember one thing, for your one single numpy array the data types will be always same. But again we can actually, like, we don't have to bother, or we don't have to worry about that much in detail at this moment. The more you will like exposed to the data set or actual real world data, then you will be able to figure out how you can, like, overcome this limitation of the numpy library. But again, numpy is there are many benefits available for numpy. So first and most important thing I'm just going to tell you, for example, let me just take a list in Python. List this, like list, then range. Okay, so this is creating a Python list. So what happens if you, and let me create another numpy array with this thing, like np dot arrange 1 2 3 4. Don't worry about all these things, I will explain each and everything. So this is also kind of same. So now if you do a sum, like this, list underscore sum, this, and let me sum up all this thing. I'm using the numpy sum function and just do it b. So np, oh, not sure why it is saying, okay. So this is the same thing, same result. You guys will be kind of feeling like, what am I doing over here? So don't worry. So the fun part starts now. This is the magic function of IPython. So now let's try this one. How much time it will take to do this operation? Okay, so this is the time. And now let's take the other one on the numpy thing. See, it was almost 6 times when you are using list. So if you can understand, if you just increase your data size in case of real world example, like, then what is going to happen? Like, the reason is I think it is 1 2 3 4 5 6 7. 1 2 3 4 5 6. That's why. Okay, you can see it is almost eighth time. First it was sixth time, then it is eighth time. The more the data size or data volume will increase, the more the time will be increased for list. So from the layman term or the layman language, for anyone, like for a schoolgoer, for a college kids also, it is now clear that NumPy, the processing time or the processing speed for NumPy arrays are much faster than the list, right? But why? The next question is why. So let me make it open for some time. So I will just explain you. So if you guys want to have this code, okay, let me just delete this lines, then it will be easier for you guys to see the code in between. Okay, you can just, if someone is just copying the code, it will be easier for you. I think so. Why NumPy is faster? Just list so please it is holding the address of the data, and case of NumPy it is holding the actual data. So this is the main reason. So just let me copy, put it over here, delete it. Okay, so this is clear now. So the next thing is that I will show you how you can create NumPy arrays and what are the different types of like methods available and how you can like use this methods and where you can use it, what is beneficial in with respect to word operation and other stuff. So let's get started. So like I just forget the this thing, like how to use this sort of things like the shortcuts. Let me check, just give me a minute. Okay, not sure why this is not working. Okay, now this is working. I need to just use escape. Okay, so this is fun. So okay, so let's start. So we're creating a NumPy array using p.array 1 minus 1 0 0. Okay, okay, fine. So let's check this data type and the type in 64 and shape means like dimension of like each axis. This is having only one axis because this is having only one row. And someone will ask why comma and 4? No, this is not comma, this is not 4, like that. This is a tuple is always represented as this. I hope you understand. And next thing is that in dim means dimension. What is the dimension? So this is one dimension array in dot size. This everything is clear. So if you guys want to see something more, you can do this. Everything will be represented here, like np think not everything. mm, size. Okay, we'll see this later. Then there is one thing important, like let's do this. This is division by 0. Now let's do one thing. Let's do one thing like 1 divided by 0. Let's see what is happening. Infinity, infinity, nan, nan. 0 by 0 something is nan, and other things are infinity. So as I told you, this is mostly used for mathematical or statistical operations and for machine learning things. So if you can see, it is probably giving this infinite kind of a thing. So this is interesting. So now next thing, I'm just creating another array. Np dot array. You can create the dimension like this. So this will be like 2-dimensional array, but I'm not going to do that. This is a very this kind of very boring, and I can do some errors as well. So just for sake of showing, and I'm just doing it. So if you can see that in dot dim, sorry, it will be dim. So 2-dimensional dot shape. It will be 2 2 like axis 2 and column will be 2 like this. So a dot size, it will be again 4, a dot item size, so 8. So now the next thing is that how we can create 3-dimensional array. So let's create one np dot arrange. Arrange is like, I'm just telling you, 0 to 51. So what it will do, it will start from 0, it will go up to 50, not including the last element, and every time it will be increased by 1. So if you see this one, so there are total 50 elements, right? So we can reshape it using this one, and let me just, we have total 50 elements. We can reshape it like 5 by 5. No, I think we can do it like 10 by 5, 10 row 5 columns. See, we can just make it a, let's make it a 3-dimensional array. Right, is that fine? We are having fun, right? Okay, so this is one way of creating NumPy arrays, like arrange, and this thing. If you can change it like, then it will be only 25, I believe. Let's check it. See, it starts with 0 and every time it is getting increased by 2, but it not including the last element. But again, we can do it. I didn't remember this thing. We can use some argument, or we have to pass something, some keywords, so include that. Now the next thing is that we can make it as a row by column. Sorry, we can make it as a transpose, like whatever is in the row it will become column, and whatever in the column it will become row. So if you do it, so it became transpose, and again we can change it like See, again we got the actual thing. So what we have learned till now, we have seen why NumPy array is faster. Then we saw what are the different information oriented like methods are available for keywords are available for getting the information from NumPy array, how we can create NumPy arrays, how you can uh, create multi-dimensional NumPy array. This is just one process. How you can reshape our array, how you can transpose thing. Like the next thing is that I'll be going to show you like the other things like sorry I forgot how we can create NumPy arrays in a different ways. So there are 2-3 more types ways are available where we can create it. So we'll be using that now. So let's create another NumPy array using np dot this is linspace, and here it will be like 0 to 15, and I need equidistance like 8 point. And if you see, so in arrange we are just giving until which point our data should go, and what will be the like what will be the, the difference between each data point. And here what are you doing, we are giving the start and end, and we are giving the how many elements will be there. I just said it should start from 0 and it will end to 15, but 15 will be that will be not included, and every data point should have the difference between 8. So not 8, it will be there will be total 8 data points, and it will be equally distributed among between 0 to 15. So 1 2 3 4 5 6 7 and 8. If you see, is it clear? Okay, so we can make it 9 as well, and see 1 2 3 4 5 6 7 8 9. So this is kind of we can create using this. Then there is something called, I don't remember, let me just, lean space is there, I think log space is there. Like I'd never used this before, maybe, I'm not sure what is that. Let me try. 1 2 3 4 5 6 7 8. So if you're not knowing something, the best friend is like this. It will tell you it linear space sequence start from the base to the power start, and hence the base and stop will be the endpoint. Start stop endpoint true, base 10, and d type. By default the base will be 10. So this will be our starting, it will be our end, and it will be divided by this one. So between log 0 to log 15, whatever value is there, it will be divided by this. But anyways, you guys can uh, go through the documentation from the NumPy official website. Let's have something interesting like np dot zeros like 1 comma 1 thing. It should throw some error. It's no attribute zeros. Okay, p dot zeros 1 comma 1 2. Data type not understood. Think type okay. So if you give like this, create there is another way of doing it, like once, and if we 8, see, so every operation in NumPy is element wise, like I just multiply this thing with 8 and all the elements become things. So there is two important things, ones and zeros. Like I just shown something with zeros as well, like this there, right? All right, so let me just make it like this. See, so zeros, ones now, and another thing is called something called empty. We dot empty. Mm. Okay, so this is something garbage, not zero. Okay, so now the next thing is that how you are actually getting the elements from a NumPy array, or how you can get the elements from NumPy array using their index. So you guys want to like see this thing, or I think I have started. Let me just keep it open up to this, so if someone is copying, so it will be easier for him. So it is, the time is now 17:56, if you can see in my watch. So I will start again from 6 o'clock, just 4 minutes for the thing. So I'll just, after every 1.5 minutes, I will just make it like this. So let me, okay, I think this is fine. If someone is copy pasting from here, I think, okay, just do it. I think, let me just make it like this. Well, 2 minutes more. Okay, so int type in by objectors type. This is float, so you can change it to type equals to int in this way you can change the data type for any numpy arrays. Okay, this is also interesting. The next thing is that let me create something called a equals to np dot array 1 2 4 16. Okay, teacher rate integers not defined d type. Okay, so if you are creating array with a custom data type, it will show. If you are not changing the data type, it will not show. So it will never like possible to view over here. For example, if I create another numpy array with the same thing, like so this is not coming. Why it is coming? I just changed the data type. So now the question is that if I multiply this fine, now strange, why this is changed actually, why it became like this, and why, for example, into 4, it should be 40,000. Why this is 25,000 something, and why this is not 16,000? Why this is like this? There is something weird, right? This is called integer overflow. Like our data type size is this, so you start calculating from the negative side. So you guys can just go to the Google and go search for this call. This is called integer overflow. So this is something interesting. So while designing your data structure or designing your algorithm in terms of machine learning, or when you are working with a huge number of data set, just consider all these things. Okay, the next thing is that let me first create one array. Range 500 100 means then let me 0 to 91, and let me reshape it with this thing. Guys, I'm just getting a call, so we'll be back in a few moments. Well, let me just reshape it like okay, first let me, so this is kind of 90 elements. So if I make it a three-dimensional array with 3, then each element should be 30 30 30. Then let's make it 5 row 6 column. So this is our array, test array, where we are going to do some fun stuff. So if you want to get this 0 thing, how are you going to get this 0? Any idea? Okay, it will be like 0 0 0. Sorry. Is it clear? Okay, we have three-dimensional array. Sorry, we have uh, our whole array is a three-dimensional array. So this is one axis, this is row-wise one axis, this is another axis, like this columns. So how many arrays we are having? Like three-dimensional column, like 1 2 3. So this is 0th, this is first, this is second. So 0 means we are pointing to this array. Then we'll count as a row wise, like 0 means 0 here. Then we are again going column wise, axis wise. You mean our last axis 0. So for example, if you're going to get this 37, what will be our like uh, thing indexing index wise? Like it is in the, this is first, this is 0, this is first array. So first is first. Then this is on our second row. This means in this array this is in the second row. Then it will be 1. Then in column wise it is our second column, like first column, no, this is first column, this is second column, so this is again 1. See, for example, if you're trying to get 75, so this is the last one, last array, so this will be definitely 2. Then which row? 75 is in the third row, it means 2. And in which column? 0, first, second, third, 3. Hope this is clear. I think we are having fun with this array indexing. This is not there is nothing there is no rocket science behind this. This is very easy, this is very simple. If you stick to the basic, if you're following the documentation, you are reading the documentation thoroughly, then you will be easily able to understand. And this indexing or get item calls are very important thing whenever you are doing some manipulation with your data sets, or you are doing some statistical or mathematical operation. Because until and unless if you are using the loops and other things, or for loop or while loop, this will be actually creating a lot of CPU or memory utilization. But if you know how to access those items, or manipulating, or doing some tips and tricks along with your data sets using NumPy things, then it will be like very easier for you with respect to memory optimization, as well as for creating or like developing some very good or strong or smooth sort of data models or algorithm for machine learning. Okay, so next thing is that our slicing. I think I have already covered the slicing operation in the list, but again I'm just going to do this thing. So let me just uh, print this array once more like this. So oh, okay, sorry. Okay, some of, actually I'm also live via Webex, so some of my other students are just taking notes from this thing. So I'm just keeping it open for some time, so it will be easier for understand. So just give me 2 minutes. Okay, so now the next thing is slicing. Say I want this row. Okay, how we are going to do? So slicing, like we have to collapse like this, and like this. It means everything, start to end, start to end, start to end. This means the first dimension, like everything. Second dimension means like every column. Third dimension means every column. So it will print. Now if I need this only these two things, how are I going to do this? Like definitely the last two things will be same. We need to just collapse like from one one number, like it will start from this, it will be like mhm. So now we got this thing. So we have started from first and nothing is mentioned means the remaining items until like until the last one. So we got this two and we have mentioned nothing means the complete whole set. So it is now, for example, I need only this thing, what I need there, like so first I have to come off over here, like I have to come over here. So how can we do this? Anyone having any idea? Anything? Okay, so let's try. So let me print this again. So this is what? This is the first one, right? Okay, let's try with this one. Just see what it is actually saying. You have to come up over here and you have to like this. Mm. I'm not sure what is happening over here. Okay. This is not coming. Let me make it like this. This is going to print the 2. Now if I just need this one, then this is going to print the last one. And if I start from here, I need this one, then I need the second array actually. So 0 1 2, so I need this one. So this is not working, not sure what is the problem here. Let me think. Okay, so if you, what is going to print, this is going to print the first dimension, right? So I have to come up here, then I have to like 0, and I have to need everything. So this is the actual like slicing, and this is the get item calls. Like first I have to collapse one dimension, and using this too, like now if you see, using this I have collapsed one dimension, and I have using this one get item I have collapsed another dimension. So initially I was 3-dimensional, now I am having just only one thing. So for say if you need this too, how many get item calls are required? Only one. So say first I have to come up over here like this, and after that I have to slice like in the row wise. So which row I need? Like from here to last, 0 1 2 3. So 3, see, it's working. But don't say that I need this like this and this. For this we need something different. This will not work over here. So let's try something different. For example, I need this one. Like again I am collapsing 2-dimension, like I need only one things. Then what is required? Then probably will be required one get item call, uh, two get item one get item call and two slicing call, because we are just collapsing one. So first will be 0. I need actually this one. Then in the row we need this one only. Then I need 0 1 0 1 2 3, and in that row I need everything. So now for say I just need only this 17 and 20 23. Maybe I need just 17 and 23, this thing. Then first I have to come off, I have to get these two things first. Okay, so 0 1, 3, like what I need, I have to, this also 2 dimensions, so I need 2 get item calls, sorry, 1 get item calls. So this is 0. Then I need this first. Let me print this one. Then what it will be like 0. Then the slicing will be 0 1 2 2 2 3. Let's try this. So this, now I need the 17 and 23. So I have to again collapse 0 1 2 3 4 5. If I need 17 and 23, how I am going to get that? Any idea? Like 0 1 2 3 0 1 2 3 4. Probably like this. Let's check. But this is printing 1622 1723. So what is required? Like this. Cool, pretty much. So the, if you are collapsing in the dimension wise, you have to need get item calls, but if you are not collapsing, you need just slicing. For example, here I'm just from 3-dimension I'm just getting 2 dimensions, so I need only one get item calls, and I need 2 slicing call, because I'm in the, if you are going to one dimension, so you need only one slicing call to get item calls, because three dimension to one dimension you have to collapse two dimension down. So for that you need to get item calls. From each means get item call, you need one specific element. From here I got this one, from here I got this one. So this is also fine, get items and slicing. So let's make it open for another 2-3 minutes for understanding purpose. Okay, so now there is another fun thing, like hmm, say if you just giving 2, and if you are giving 2 3 1, it is going to print some items like this. But if I say I want to create another array by having the element using some index wise, like get item things, so that is called um, fancy indexing. I'm not sure why this name is given, so this is like this. For say if you need uh, uh, three dimension, like for example 1 1 1, what is going to print? 1 1 and 1 means first this one 0 0 first, then this is first 36 and this is first 37. So this is creating an array, nice array. Here if you print like 1 1, so this is the difference. So now you can use it like 2 3 3. What is 2? This is 2. What is 3? 0 1 2 3 78. And what is 3? This side 0 1 2 3 81. This should print 37 81. See, so this is called fancy indexing. This is nice, right? Like this will be very useful when you are dealing with some sort of like manipulation or some sort of sorting or some sort of comparison using two different types of data sets and all. So for example, if you are having like uh, um, one numpy arrays, like this is your this is some sort of keys and this is some sort of values. So you want to create a list uh, from that, like key value combination. So in that case this will be very very important. So if you can just write down your arrays using like fancy indexing, so it will be like this. For example, say 37 and 81. If you know the combination and all, you can do anything like mix and match, sorting, like whatever things you are required. I'm not sure, like probably many things. So let me try some other things, like another thing like 0 1. Let me put 0 2 3. Let's try. So 15. Let's check why 15. 0, then 2 1 2. 15 is 3. 0 1 2 3 15. This is nice. So fancy indexing is also done. So I think I have covered almost all the basics or necessary like methods or operations or like mm, types of operations are possible using NumPy's arrays, but this is not the like complete thing. There are much more things are available, many things are available. I'm just giving you the basic which is actually required to enable you to do some like data set data analysis, or data you can play around with some data and all. So uh, i'm just I'm just stopping this session now, and probably going to add one more or two more session to this soon, probably today or day after tomorrow. So I hope you guys have enjoyed this session. So see you soon. Just subscribe to our channel and don't forget to hit the bell icon to get some more updates. So see you guys. See you in the next video. Bye all. Well, the next thing is also very important and interesting. So for example, I want to check from from my array what are the elements are actually divisible by 2. It means like equals to equals to 0. See, so when or like we are using this sort of condition, it will go and check and it will put the true values if the condition satisfies. So this is called mask. So we are doing some masking. For example, 0 to this is false, this is true, this is false, this is true. So this you get it right. So now if you want to see the values actually, which is actually like this, okay, let's call it as a mask. And mask, see, this is actually printing the elements. And if you want to see np dot where the locations actually, and mask, it will also generate the locations. I'm not sure. This is the first array. Array of 0, 1, 2, 3. I'm not sure like why, how many arrays are there. 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2. What is this? I'm not sure like why it is printing like this. Something strange. Not sure. Not sure like why it is printing like this. Okay. 0. Okay, I got it now. So 0, 0, 1, 0, 2, 4. So basically the first element is 0, the 0, 0, 0. The second element is 2. It should be 0, 1, 1. Not sure. Like, let me try something different with then it will be easier to understand. np dot arrange mask equals to 0 np dot where okay. So why this is not printing the locations, I'm not sure. It's kind of strange for me. No, I think p dot where it's supposed to print the locations. I'm not sure why it is not printing this. Why every time this is printing? Let me try np dot where is in x dot good values. Okay, np dot where I'm not sure, like good values. Finding this that are p dot 0110 like in true false. Parameters where conditions and xy. xy return the elements either from x or y depending on the condition. If only condition is given, only conditions dot non-zero. But the thing is that it is printing one good values x. What is x? I'm not sure. np is in x good values. True, false, 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 true. I'm not sure why it is not printing the locations. Either both x and y should be given. I'm not sure what is x and what is y. This is something strange. Like, I never had this before, this problem. Okay, let me try these things actually. Array, this thing. dot x get up then 5 array 5 shift 3 3 0 1 2 array 2 2 2 the result is 1d square mask, then x minus 1 too many indices in the array think 0 1 2 0 2 3 4 6 7 8 9 10 11 12 13 14 15 16 16 17 18 19 20 21 22 okay 6 divided by 5 I think now this is working. Yes, now this is working. So what you have to do, you have to change this thing. So this is basically the indexes where the things are actually available, in which location this is actually available. I'm not sure why this is printing this thing, so let's make it like a. No, too many indices. too many indices, I'm not sure. A 5 equals to 0. Yes, this is fine. So there is something strange. So this is our condition. This is where. So this is printing the indices. So if we a dot max, so this will print the max like this. This is some fun part again. A dot min. So this is 0. A dot this will print the index element of the minimum item, and this is index of the maximum element. So quite completed, all these things are done. So don't worry guys, I will upload this whole Jupyter notebook into the into our GitHub repository, so you guys will able to understand. So the next thing is that how to find how many elements are there in your, like for example A is this. So just let's make a small array, like p dot array with ones. Yeah. Okay, so now A A2 into 2 1 0 1 2. Not sure what is happening here. Mm, 0 2 into 2. Okay, okay. Oh 2 4 1 2 2. Let's 0 4 is 0 4 into 2. Okay, so we have 1 2 3. We have some elements which is duplicated and some elements which is unique. So A 0 1 2 3 4 5 6 7, 0 comma 7 equals to 5. So this is our resulting array. So now if I am to count like how many like unique elements are there, so what you have to do like this. Okay, this is not possible to do over here. Unhashable numpy array. I'm not sure why this is not working. Unique array a dot. We want to finalize the count of element, like how many elements are there. A dot p dot bin count object to div for desired array. I'm not sure what is happening. Like, just hold on a bit. Well, so this is our array. So let's unique u c equals to p dot unique. Okay, first c and p dot unique a. If I print c 1 2 4 5, so this is giving us the set. Okay, so like okay, this is again throwing some error. In p dot unique a return count equals to true. I think this is the right one. I'm not sure like what is the problem over here. Let me check in p like dot unique okay let's me return count. Okay, return numbers. Let me check actually first. Think where it is. Return underscore to. Just let's give a try. Return underscore count is not working over here. Let's try this. Okay, so if I print c, this is c. If I print d, 4214. Okay, so now what I have to do, this is actually giving one dictionary. So zip, then I have to use like c. I think See, yeah, and D is fine, I think. Yes, 1 is 4 time, 2 is 2 time, 4 is 1 time, 5 is 1 time. So this is quite interesting. Like this is, if you this thing, it will unpack two values, like with assigned to, one will be assigned with C, one will be assigned with D, and after that you have to just use thing. Another one, you can use it using collection, like non-numpy technique. You can use like using collections, and you just have to use in, for example, import, I think the import collections, and after that you have to just call like collections dot counter on a unhashable collections. Why this is not working, I'm not sure. Like unhashable type numpy array. Not sure this is why this is not working, but probably it should work. Let me just do a Google over here. Uh, mm, not sure. Okay. Let me search it, because I have done this in the past. I think yes. There are many ways of doing this, but this is the right solution. If you can see, someone else also posted in the Stack Overflow, but this is not working. I'm not sure why this is not working, but not sure, not sure. Like collections, import collections, like collections is not defined. I think there is another way of doing this. Just take it in a list. One set of list one list one equals to list of list, but when I'm applying unhashable type, not sure. Well, this is almost we have covered many things. Like there is one more thing I can show you. Like let's create one text file, for example, like like A B C 1 2 3 4 5 6 6 7 8 9. Rename and okay, np dot okay. np dot names delimiter com names not sure, like see like A, comma B, comma something strange, not working. Let's try something different. Like, I'm not sure why this is not working. Skip header 0. Okay. So array 1, 2, 3, 4, 5, 6, 7, 8, 9. C0 1, 2, 3. Okay. So we have loaded one like this thing column wise. So what next? Like meter equals to like this. So quite okay now. So for example, this is one calendar week for say for a given or sorry, this is kind of a data for one particular like stock market's share price. So you would like to identify like in which like position the value is like maximum. Like as I told you, now you can do c dot so easily now you can understand that number 8 is the maximum and like which position it is the 8th position like 0 1 2 4 5 6 7 8 0 1 2 4 5 6 7 8 9 arc max this one the maximum but see arc min like 0 like the first one is this last one is this 8 so what if I print 8 like 0 1 2 1 2 3 but why the question is that why this is giving this so I'm not sure, like this is kind of this is flatten the thing, and after that probably this is min the index 0 1 2, probably c dot flatten 0 1 2 3 4 5 6 7 8. So okay, it means this is flatten the thing, and after that this is returning the index. So after that, if you just do it, so this is quite an interesting thing. Like if you're having a like list of CSV file, you can load it into your NumPy array using delimited things and all, and after that you can do some sort of operation. So I was also not sure about this thing, so I just came to know at this moment, like this is actually flatten the array first. Flatten means if you're having two-dimensional array, it is going to be flattened like this kind of a thing. So if you see, this is like the orders are maintained like 1 2 3 4 5 6. It is not like row wise or column wise like transpose. So what other things are still left? I'm just thinking if still something is missing. This is completed. One important thing is that let me create one like thing. Let me just try. I'm not sure. Let me check if I'm having some CSV file here or not. Okay. I'm not sure whether I'm having some CSV files or not. Desktop, Jupyter. I think I'll be having some value. I'm not sure. If I'm having some value, then I can show you. Let me just open this one. Okay, I'm having some value. So let me open a notebook over here. df equals to pd dot .csv, df equals to this. So this is our CSV, df dot now. If you check the types of df dot NumPy array, so whatever you are seeing inside the data frame, this is actually the NumPy array. So you can flatten this thing if I'm not wrong, like df dot values dot see, it's becoming a single kind of an array. So everything is kind of related with NumPy arrays. If you do something very closely, you'll be able to understand. So the next thing what I was supposed to do, like I just forgot, like okay, so let's say I'm having np dot empty 1. One column, one row, it two column. And let's try with this, and d type equals to integer. Let's try this one first. So okay, this kind of integer value, don't worry about that. So now what I'm trying to do, like say np dot vstack comma 2 comma 2. See, this is stacking up. Like if you are, let's say a, so what is the new element, like this, then again a, like 3, so you can just stack up the arrays like in a nice way. So this is also very useful, will be very useful when you are doing some sort of mathematical operation mostly related to your linear algebra or kind of system of linear equation and all, and maybe some other possible areas. Another thing is called h stack, like everything will be like horizontal. Now everything is like this way in this order, and h stack will be this way, like column wise. So let's say, let's create another, let's, this is our array. So now let's make it like this and do it h stack, and it will be like all must have the same number of dimension. I'm not sure what is happening over here. Okay, understood. When but 2 given 1 3 3 3 thing, this should work now. Okay, it's one takes one positional parameter, but 2 given first, second, not sure what is the problem. Let's go here and check it. One, two, two, three, three, four. Not sure what is happening. H stack. Okay. All input in the same direction. Well, not sure why this is not working. Takes one positional argument but two given. It's take 333 0 1 2. Not sure what is the problem over here. Still thinking. Stack is like 3 2. I was thinking like why this is not able to do it. Like okay, the H stack will only work. Okay, there is some limitation probably on H stack, like all dimensions probably. Like let me check. 3, 3, 2. All input arrays must be have the same dimensions. Okay. So here what I have to do, how many rows are there? 1 2 3. Okay, so it will be like np dot array, it was array 1 2 3, like 9. So if you see, now this is working. So it is actually the thing is that it requires the same number of rows for each stack. So in the first thing we are having 3 rows, so that is why it is we need 3 rows. So it's kind of strange, but again, this is how it works. Okay, so I'm thinking what else is still pending, like everything is pretty much covered in this NumPy series. So okay, one more thing, like suppose we are having some equation like 2x plus 2y equals to 10 and 3x plus 3y equals to 9 plus 2 6 15. So if you want to resolve this equation, like we can do using NumPy arrays. So what you have to do, you have to just write the things like this, NumPy dot array. Inside that you have to just pass the coefficient like 2 comma 2, and then the another one is 3 3, just a normal matrix form, and b is like your 10 15, like np dot array and 10 comma 15. Just okay, now if you remember, like what will be the value of x? The value of x will be like np dot len alg dot solve a comma b. X will be 2, y will be 3, and if you do it like okay, 0 and 0 and 5 also will work. Let's see, this was our thing. 2x plus 2y equals to 10 and 3x plus 3y equals to 15. Yes, this is fine. Now let's change a bit. 20. See, still this is working. So we can solve linear, like system of linear equation using this NumPy arrays as well. So what else is possible using NumPy arrays? Like you can plot some graph, like import matplotlib dot py plot as plt dot matplotlib no module matplot. There's some typo like plt plt.scatter. What is the value of a? Let's I forgot actually. A dot a equals to a dot flatten, b equals to a into 3. Let's check what is the value of b. So 6. So let's plot plt dot scatter equals to a comma b. Okay, so this is quite funny. Like b equals to np dot sign of a, b equals to this equals to this 0.9. I think some values are same almost. So let's change it like arrange 0 to 5. 0.4. See, this is a nice sine curve. So these things can be plotted like using any sort of like graphs and all from NumPy arrays and all these things. So this is not the this is not the right forum or right time to talk about matplotlib, but anyways I'm just giving you some sort of things like. But anyways guys, you guys can go ahead and start looking for the documentation in NumPy arrays. It is huge. Sometimes I'm also start forgetting things, so I just do use Google, Stack Overflow, Kaggle and the usual documentation. But whatever I am covering till now, this is the most essential thing if you're going to start machine learning. And in coming days I'm also going to write like few more things on top of that. But again, there are like some other things are also possible using NumPy arrays, like how can I say, like those things like you can modify or you can manipulate. You can take dictionary values from your NumPy arrays. Sorry, from dictionary to NumPy arrays. You can create dictionaries from NumPy arrays. You can create like data frame from NumPy arrays, like too many things. For example, you are having like these things. For example, say np dot a equals to np dot array like this. Let's say Ronnie, Homu, Rahul, Virat. Okay, so this is one numpy array, and if you're going to create, like, it will be like pd data frame, then you have to give like this, and then you have to columns, let's say a comma b comma c, a b c d, a b c d. Shape some indices. Shape is passed 1 by 4, indices imply 4 by 4. Let's okay, let's make it like 2 by 2. See, we just now have created like pandas data frame from numpy arrays, so this is quite efficient. See, cool. So there are many things are possible, not only these things. I'm just thinking, so guys, I think we should stop this video at this moment over here. There are too many things. I have to just modify this notebook, and I'll going to upload the whole thing in a nice looking format inside our GitHub repositories, and uh, probably I'm going to start another series on like linear algebra. So I'm thinking like Mm, why? Okay, okay. So in my next video, what I'll do, I will create one Python program using NumPy arrays, linear algebra, like functions, whatever available in NumPy arrays, and other like things to to create a program which can able to solve any number of linear equation using any number of variables starting from x to xn. So I think this will be the right and correct direction. So it will be it will give you guys some sort of insight about our linear algebra things for doing linear regression. So in the next week videos, I'm just going to upload the videos on that linear equation solving problem, and after that I'm right away start doing some data analysis using the real data sets, and after that probably I'll be doing these things for 4 or 5 different data sets using matplotlib and all. Before that I'll be going to publish one more videos on matplotlib, and after that I'll be starting with linear regression. No, before that I'll be going to deep dive into the theoretical part of machine learning, and after that I'll be going to start with the linear regression with one variable, then multiple variable, and after that logistic regression, and after that we'll be doing the other things like initially I'll be covering the supervised learning portion, and after that I'll be going to start with the unsupervised learning portion, and definitely I'll be going to cover some real life data sets and data models which are available in the Kaggle and other like public repositories. So that's all guys for today. Hope you like the videos, and sorry for wasting your time like much, but you can understand like I'm not copy pasting from anywhere. Like these contents are completely created by me. I'm doing it on live on like kind of real time, so mistakes can happen, and as I told you, I'm not an expert. I'm a seeker. Like I've started learning these things like 4 or 5 months ago, and again everything from YouTube, like GitHub, like other repositories, or some Kaggle, some famous YouTuber channel like I just can't remember the name. Mostly from Cody and Hitesh. He's an Indian YouTuber, but his videos are awesome. I'm just giving thanks to him. And the other channels are available over there. Many channels. There is one from like Naveen Reddy's channel called Telescope. That is also quite impressive. So I also get to know too many things from there, and also our good and best friend Stack Overflow. So there is nothing to hide, nothing like ashamed about it that I start doing copy pasting from other channel. No, I'm not doing that. Whatever I learn, I'm learn from there, and after that I'm completely putting into my real life examples and things. So give it back to the community. So hope you guys enjoy my video. If you are at all having any problem or you want to have something more from our side, just put a nice comment inside the description, sorry, inside the comment box. If you want to have something more, you can mention. If you want to have something like, if you want something we should change, please do let us know. And also you can follow our Kaggle channel, sorry, Kaggle repository. I have just uploaded 2 or 3 kernels over there, so you also can follow me over there. And for the time being, just subscribe to our channel, hit the bell icon, and share these videos with your friends if you are thinking that this video is going to help you and is going to change or add some value to your existing career, whatever you are working. So that's all, guys. See you next time. Bye bye. So guys, one last thing before closing this video. So like a few minutes ago, I have just we're just facing some problem with this thing. Like where is this one? Like arcmin and arcmax was not giving the correct dimension. So what I assume that it is probably flattening the data structure, this one, and then just printing the index. So there is another way we can find this. Like this is our array C, losses C, for example C. Now I want to find the minimum thing of this thing. Like there are 2 sheets, so it will always return the first one. Like just check. So how you are going to do this? Like np dot variable index, like np dot arc min, like a axis equals to none, and then dot shape. So 0 0. So you can understand, like the next thing will be that if there is more than one element, how you can going to find that. So what is this? Like C 0 0 is 1. So let's create another variable and let me assign this with 0 0. So it will be this, and after that just create one mask, like C equals to B, and np dot where this one, like, and inside that just create this thing. See, array 1 1, there are 2 values. So that's all, guys. So see you in the next video. Bye, and thanks for watching our channel, and thanks for subscribing to our channel.